Hi guys, today we are going to discuss about the closure property. So let's quickly see what a closure property is. Okay, so closure property. I'm so sorry, it has to be C. Okay, so this is C. Okay, so it's a closure property. Now, what is a closure property? Before I delve into what closure property is, what are different type of numbers? Let's look at what are different type of numbers we have. Okay, so we have natural numbers, we have whole numbers, then we have integers, then we have rational numbers, then we have irrational numbers and so on. Okay, so there are different type of numbers in there are different type of numbers we know as of now, and then there are different operations we do on these numbers, right? So what are these operations? We do plus, which is addition, then we do subtraction, right? Just guys, wait a second. Yes. um Let me just quickly again share the screen. Yes. So there is a subtraction, right? Then there is multiplication, and then there is a division. So these are the four operations which we have learned to apply on these numbers, right? So now what does closure property tells us? Okay, so closure property tells me that if I am applying any operation on a given type of number, okay, so suppose if right now let's take natural number, okay, and if I'm doing any operation on a natural number. So let's take, we are taking addition as an operation. And if I take natural number, if I add two natural numbers, and if as an answer also, if I get natural number, then what do I say? I say that natural numbers are closed under addition. Okay. Now, what does this statement means? This statement means that whenever I am going to perform an operation on two natural numbers, I'm always going to get a natural number. Okay. So, and if I'm always going to add two natural numbers, and if I get a natural number as an answer, it means that natural numbers are closed under addition. Okay. So that's what closure property means. Closure property means that if you're adding or if you're performing any operation on any one type of number, and if you get the same type as an answer, then means that that type is closed under that operation. Okay, so here what is the type which we are using? We are using the type as natural number. What is the operation we are doing? We are doing addition as an operation. And what I'm going, if I'm getting the same type as an answer, that means that this type, that is natural number, is closed under addition. Okay, that's what is the meaning of closure property for natural numbers. So here let's see if natural numbers are closed under addition or not. Okay, so let's see what are the natural numbers. We know natural numbers are counting numbers. It starts from 1 to infinity. So let me just pick up any natural number. So 1 is a natural number. Let me take another natural number, which is 59. So if I add 1 plus 59, I get 60, right? So if I see 60 is also a natural number, right? So it means that when I'm adding two natural numbers, I'm getting a natural number. So I have proved, I have thought of such numbers. Now let me think all the natural numbers and think of if I can come up with any one set of natural numbers. If I'm adding and I'm not getting a natural number, can I think of any such pair? Um, Not right now, right? So I'm not able to think of any such pair of two natural numbers such that when I add them and I'm not getting a natural number. Because if I'm able to think of such a pair, then it disproves this, right? Then I'm fine. I'm able, then I can't say that natural numbers are closed under addition, right? So in this thing, so whenever, if I see all the examples, if I take any two natural numbers, whenever I'm adding two natural numbers, I'm getting a natural number as an answer, which means that natural numbers are closed under addition. Now, if something like this is written to me, now how to interpret this statement is also very, very important. Okay. So suppose something like this is given to me, that natural numbers are closed under addition. If someone tells you this, what does it mean? Okay. Right now, though, I'm explaining you, but if someone tells you, natural numbers are closed under addition, what does it mean for you? It means that whenever you add any two natural numbers, you are always going to get a natural number as an answer. So it means that it is universally true that whenever you are adding, what is the operation they're talking about? Addition. So that's why I've written addition. What type of number they are talking about? Natural numbers. So I'm going to add two natural numbers. So it means that whenever I'm going to add any two natural numbers, I'm always remember, there is a always is a very important keyword here. So whenever I'm going to add two natural numbers, I'm always going to get natural number as an answer. Okay, so always is meaning, so whenever, it means that it is true for all the natural numbers. Okay, it is true for all the natural numbers. It is, this is the meaning of this statement, that natural numbers are closed under addition. Okay, now let's see about subtraction. Okay, are natural numbers are closed under subtraction or not? Okay, let's find out if they are. Okay, let's quickly check. Let me just rub this. Okay. Yes. Yeah. So let's take two natural numbers. I have taken natural number as one natural number as 5, and I'm taking another natural number as 7. Now, when I'm doing 5 minus 7, what I'm getting? Minus 2. Okay, but I know negative numbers do not come under natural numbers, right? So it means that whenever I'm subtracting two natural numbers, it is not necessary that I'm getting natural number as an answer, right? So this is one natural number, this is another natural number, and what operation I'm doing? I'm doing the operation as subtraction. That is my operation which I'm performing. And what is the answer I got? The answer which I got is an integer. It's not a natural number. So it means that natural numbers are not closed under subtraction, right? What does it mean? How does it look like in equation? It means that if I am subtracting one natural number from another natural number, it is not always necessary. So not always, please stress on this term. I'm stressing on this term, that is not always necessary. Okay, so it's going to be not always necessary. So I'm going to write not always necessary that it is going to be a natural number. Okay, but it doesn't mean that whenever I'm subtracting two natural numbers, I'm not going to get a natural number. I might get a natural number, right? So if I write 5 minus 2, which is 3, sometimes I get natural numbers, sometimes I don't get natural numbers. But when can I say, when can I make this as a property? If it is true for all the natural numbers under subtraction. But I saw it is not possible for all the natural numbers, if I subtract two natural numbers, to give me a natural number as an answer. That's why I'm saying that natural numbers are not closed under subtraction. Understood? Now let's see, let's quickly check with subtraction and division as well. Okay, so sorry, division and multiplication as well, right? Now let's talk about multiplication. Let me just take another. Let's talk about multiplication, right? Okay. So if I talk about multiplication, so what I'm trying to prove, that I'm trying to find basically, is if I multiply a one natural number with another natural number, am I getting a natural number as an answer or not? Okay, that's what I'm trying to find out here? I think about, let me take some examples to see whether this holds true or not. So I took 4 into 2, I got 4 twos are 8. Then maybe I took 11 into 11, I got 121. So I'm just trying to take some peculiar numbers and check if I'm getting getting answer as a natural number or not. So even if I take one big number into one big number, I'm this the resultant number which I'm going to get is again a natural number. So what I saw that if I'm multiplying two natural numbers, I'm actually getting a natural number as an answer, right? So 8 is a natural number. So similarly, if I'm multiplying 11 into 11, again what I'm getting 121, which is again a natural number. So I'm not till now I'm not able to find any such number where I can say that it's where I can say that when I'm multiplying two natural numbers, I'm not getting a natural number as an answer, right? So if I'm multiplying 121 into 121, 121 is a natural number, and 14641 is again a natural number. So if we see and if we do such operations again and again on natural numbers like multiplication, we will find that whenever we are multiplying two natural numbers, we are always, so here again, we are always getting a natural number as an answer, right? So what I'm going to say is, so what I would say is natural numbers are are closed under under multiplication. Okay, now why I'm able to say that? I'm able to say that because when I check, because all the natural numbers follow this, it means that always and always whenever you are going to multiply one natural number with another natural number, I'm always going to get natural number as an answer. And that's why I can write it as a property now, that natural numbers are closed under multiplication. Understood? Now let's check for division. Now how does it look like for division? Let me just rub this. Now let's check out for division. Yes. Let me take this pen and let's take division. Okay. Now what I have to prove, that if I divide a natural number with a natural number, I should get natural number as an answer always. If I'm getting this as always, then I can say that natural numbers are closed under division. But even if if I'm able to find one example where I'm dividing natural number by a natural number, and I'm not getting a natural number as an answer, then I know there is a problem, right? Then it's not closed under natural numbers. So under division. So let's see. Let's take 6 as an answer and another natural number as 3, right? So I took one natural number as 6, another number as again a natural number which is 3. Now let's see, 3 2s are 6. So which is 2? 2 is again a natural number. So in my first example, it is satisfying this condition, right? Now let me take another example. Let me take 5 divided by 2, right? 2 twos are 4, 2.5. I got 2.5 as an answer, but I know 2.5 is not a natural number, right? So I have found one case where when I'm dividing two natural numbers and my answer is not a natural number. So in this case, what I would say is natural numbers. So in this case, I'm going to write natural numbers and and wait, I'm so sorry. Okay, let me just, thank you. So natural numbers are not closed under division, because I was able to find one case where where when I'm dividing two natural numbers, I'm not getting a natural number. That's why I can't make this as a property, because I know that there are some natural numbers, when I divide them, I don't get natural number as an answer. That's why it can't be a property. That's why I would write it as natural numbers are not closed under division, right? So here what we did, we checked with one type of number this property under all the operations. Similarly, what you guys have to do, you have to check with whole numbers, integers, rational numbers, if these numbers are closed under these operations or not. So this would be a homework.